Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to be talking about how do you differentiate general brackets, okay? This rule is quite identical to the previous one when we talked about differentiating simple bracket, but in this case we're gonna have function. Don't worry, I'm going to talk about it. But before I move on, please don't forget to like, share, and subscribe. And also, don't forget to click the notification bell so when I post new videos, you'll be the first person to know. All right. So as usual, don't forget to review the laws of indices. Go to my channel. I have the laws of indices. Make sure you're conversant with the laws of indices and also the power rule, which I think is the first mechanism in this video, differentiating mechanism in this video. Make sure you look at it. Make sure you understand it because the power rule is the basis for almost all the mechanisms we're going to talk about in this series. Okay. So in this case, in the previous video, let me just put a reminder. In the previous video, what we talked about when we're talking about differentiating a simple bracket, please go back and have a look. We talked about when we have something like y is equal to ax plus b raised to the power n. Okay, simple bracket. How do you differentiate this? And I showed you how to do it. Now, but in this case, what we want to talk about is if, for instance, you have y is equal to a function. So basically, what we talk about a function, it could be a quadratic function. So for instance, you have something like y is equal to x squared plus 3x plus 7 raised to the power 20. This is a quadratic function. So in the bracket now, we're not just having simple ones like what we had the last time. We had linear equations in the last video. We talked mostly about linear functions there, where you have something like 3x plus 5 raised to the power 2. But now, in this case, now you're now having like quadratic equation in the bracket, or you're having polynomial. Maybe you're told to differentiate y is equal to x cubed plus 7x all raised to the power minus half, for instance. So in this case, now you're having functions, while in the previous ones, you were just having simple linear equations, okay? All right, so how do you differentiate this? All right, let's get straight to it. So because I know some of you do write notes, I'm going to just write what I just said so that it will be easy for you to write to your notebook. So here we are differentiating functions, all right? So here we're differentiating functions. So we have, for instance, y is equal to a function, an f of x function, all raised to the power n. So in this case, where n is the power, and the f of x is a function, okay? So it could be a function, it could be a polynomial, a quadratic equation, or it could be anything, okay? An exponent, it depends, okay? And also what I also said, I told you that this rule is identical to the previous one, all right? So this rule is identical to the previous rule we just discussed in the previous series or in the last video. What we talked about differentiating simple brackets. We talked about differentiating simple brackets. So we've talked about this earlier. Okay, so it's basically exactly, but the only difference but in this case, we have a function. So we have a function in the bracket, okay? So you could have a function like a quadratic function, a polynomial function, and an exponent. All right, so let's get straight into this. So how do you do this? So there are 4 steps or 4 rules on how to do this. Number 1, similarly to what we talked about in the simple bracket, you also bring the powers down as well. So you bring the existing power down. And you then use it to multiply. it is going to be very important that before you make sure you understood the previous one, because it's exactly has exactly the same rules like we talked about there, okay? So the next thing you have to do, you then have to subtract 1. So you subtract 1 from the old power and use the new power. Then, after you've done that, the next thing that you have to do, you then have to differentiate the function inside the bracket. So the function I'm referring to is the f of x, okay? So you're now going to differentiate the function inside the bracket, so that's the f of x, all right? Then using any of the previously discussed differentiation mechanism. Let me just write the previously, using any of the previously discussed. Okay, so any of the previously discussed mechanisms we've talked about. Then, okay, then when you're done with that, then you multiply, okay, the result with step 2. So when you're done with that, you do that, then you now what? Simplify. Okay, so I'm going to go back. So let me apply it to this f of x first before we pick an example. So let's assume we have the y is equal to, we have f of x all raised to the power n. Step 1, as usual, we're told to bring the power down and use it to multiply. So we're going to bring this power down. So it's going to be y will be equal to n f of x. Step 2, we have to subtract 1 from the old power and use, okay, the new power, right? So we're going to subtract 1 from the old power. So it's going to become n f of x. Then we have n minus 1. So basically, you bring down the n and subtract 1 from the power. That's what we've done. Then the next thing is that we then have to differentiate the function inside the bracket. So just to make it easy, okay, the function can be anything. So for me to, when you differentiate it, let's assume the answer you get is the f prime. Is that making sense? So this is the f prime you got. Then the second thing was that when you've done with that, you then have to multiply the result with step 2. So this is the answer we got from step 2. So it's going to be f prime multiplied by n f of x n minus 1. So step 4, we then what? Simplify. So that means the y over dx is going to become this multiplied by that. So it's going to give us n f prime x into f of x n minus 1. And that is the answer for that. All right. So don't worry. Let's pick an example. But basically, it's similar to when you're differentiating simple brackets. You bring the power down, you subtract 1, and what you have in the bracket, you differentiate it, and you multiply it with your answer. All right, so let's pick an example here. So here we have, what example can we, let's say we have y is equal to 3x squared plus 4x plus 5, all raised to the power what? 5. Okay, step 1. Now, what you do, you bring down the 5. So you're going to have 5 into bracket, 3x squared plus 4x plus 5. Are you seeing it? Then, step 2, We then subtract 1 from this. So we're going to have 5 into bracket 3x squared plus 4x plus what? 5. Then this will be 5 minus 1. Then that will give us 5 into bracket 3x squared plus 4x plus 5 all raised to the power 4. Now, the next part, step 3. So step 3, we have to what? Differentiate the function inside the bracket, okay? So let's go. So what is inside the bracket? We have 3x squared plus 4x plus 5. And when you differentiate this, apply the power rule. It will be 2 times 3. So please, if you've not looked at my video on how to differentiate using the power rule, please go back and have a look. So 3 times 2 will give you 6x. 2 minus 1 will give you 1, okay? Plus 4. If you differentiate 4x, it's going to give you what? 4. And when you differentiate 5, it will give you 0, okay? So usually, the 1 here is not usually written. So let me just leave it like this. All right. Then we have differentiated that. Then after differentiating that, you have to multiply the result with step 2. Okay. So we have this result. This is what we have in step 2. So it's going to become 6x plus 4. All this you're multiplying with what? 5 into bracket 3x squared plus 4x plus 5 all raised to the power what? 4. So you're going to multiply this and this now. So opening the bracket. So I've talked about opening simple brackets and double brackets in my previous video on that basic algebra. I told you that when you have A, B plus C, when you want to open the bracket, it's going to give you AB plus AC. Do you remember this? So if you've not, if you've forgotten how to expand bracket, go to the playlist. I have a video on expanding brackets, single brackets and double brackets. So the same thing, you want to multiply these two together. So it's going to be 5 times 6x. It's going to give us 30x plus 5 times 4 will give you what? 20. Okay. All this multiplied by 3x squared plus 4x plus 5 raised to the power 4. So therefore, dy over dx, if you differentiate this, should be what? 30x plus 20. And we have 3x squared plus 4x plus 5 all raised to the power what? 4. And that'll be the answer for that. So the same thing, you bring the power down, you subtract 1, the answer in the bracket, the function in the bracket, you differentiate it, and you multiply it with the answer from what? From step 2. All right, let's pick one more example. So let's say we have this. One more example. So we have y is equal to, let's say, 8x squared minus 9x. Let's say minus 2. Let's use a negative now and see what we do. So the same thing, step 1, what you do, you bring down the minus sign. So it's going to give you minus 2 into bracket, 8x squared minus 9x, okay? Step 2, the next thing you have to do, you have to subtract 1. So it's going to be minus 2, 8x squared minus 9x, minus 2 minus 1. And that will give you minus 2, 8x squared minus 9x minus 3. All right? Then we'll go to step 3. We have to differentiate what is in the bracket. So what is in the bracket we have here is 8x squared minus 9x. So when we differentiate 8x squared, it's going to give us 16x minus 9. So please, if you've not watched my video on the power rules, please go back and have a look. It's the first rule in this mechanism. All right. So please go back and have a look. Then we have 16x minus 9. Then we have to multiply this with the answer we got from step 2. So it's going to become 16x minus 9 minus times minus 2, 8x squared minus 9x all raised to the power minus 3. I remember I explained to you when you're opening the bracket, single bracket. So you have a times b will give you what? AB, and a times c will give you what? AC. So the same thing. when you want to open this bracket, it's going to be minus 2 times 16, and that'll give you minus 32x. Minus 2 times minus 9 will give you what? 18. And all this is going to multiply 8x squared minus 9x all raised to the power minus 3. So we can now say the y over the x, when you differentiate this, the answer you have will be minus 32x plus 18. And we have 8x squared minus 9x all raised to the power minus what? 3. And that is that for that. Good. All right, so I'm going to give you some examples to try. You can try these questions and see if you can solve it. We have y is equal to 3x plus 1 raised to the power minus 2. This is similar to the simple bracket from the last video. Then we have also y is equal to, we have 6x cubed plus 1 all raised to the power minus 4. Then we have another one. We have y is equal to 4x squared minus 8x plus 6 all raised to the power 4. And we have another one, y is equal to 3x squared plus 7x minus 8 all raised to the power minus 6. And in all this, I want you to find the dy over dx, so the first derivative for this, okay? And like I said, you can try this, you can discuss with your friend, put your answer in the comment section for each of them, so other students can have a look and you guys can have a discussion if you want to. And if you are still struggling, you can send me an email, or if you see me, you can stop me and ask me any question anytime. And remember, while you're doing this, the first thing to do is that you have to bring the power down first. You subtract 1, then you differentiate the function in the bracket and multiply by the answer you got in step 2. Then you simplify. All right? And that'll bring me to the end for that. So the next video, I'm going to be talking about how do you differentiate a polynomial, all right? How do you differentiate a polynomial? And quickly, before I go, I want you not to forget to subscribe and click the notification bell so that when I post the video on how to differentiate a polynomial, you'll be the first person to know. And please, if you have any questions, please don't hesitate to contact me. You can send me an email and I'll get back to you, okay? So I'll see you soon and have a nice day.